Welcome everybody to our 109th webinar that we have done during this series. This is the 35th of our second year, and just been having a great time doing these, learning just tons of information. And we have a returning guest here today with us. We have Chloé Lerin that's going to come in and talk a little bit about her passion, which is motorcycles. But then we're going to talk. We started off with Chloé with a couple of different webinars where we started off with just putting a solo and what kind of information could you get out of just a basic GPS-based data logger. And then the second webinar she co-hosted with was about adding the ECU channels, maybe a solo DL, maybe a lower, one of our data loggers with just the ECU connections in there plus the GPS. And today we're gonna expand that a little bit more, and we'll probably have another webinar in the future where we expand even more. So we're basically walking some steps. We'll share with those of you that are here live in the chat box. We'll share links to Chloé's previous webinars, and if you're watching on YouTube, anything we say we're going to share, all the links will be down in the description box below if you're watching this on YouTube afterwards. So keep that in mind. We're going to have a good time today. We're going to talk about motorcycles, but all of the data, it's whether or not it's coming from a dirt oval cart like we did last week with David Smith, or motorcycles today, or forming the cars in the future. The data is really quite similar. So a lot of what Chloé is going to share with us today, some of her experiences and what she is doing out there, goes across the board. And but there are a couple things she's going to talk about, wheelies and some other things that maybe we don't get too often in some of our other types of racing. But I think there's a lot to learn from all of our different guests that show up and join us. So let's introduce Chloé and get her up and running. Chloé, again, this is her third time she's hosted with us here. She's a race data engineer in the Moto America series, the premier motorcycle road racing series in North America. And but yet she's out there. She's an amateur club racer with her own bike. She's a track day coach. Tons of engineering and background in engines, combustions, and different things. One of the things she says down there at the bottom, one of the later bullet points, enthusiast educational video maker. She's made some interesting videos, and I know she's looking forward to do a few more. I really like what she does in that part of it as well. Chloé, welcome for joining us. I appreciate you coming again. Cover a little bit more about yourself before we get started.
Hey, Roger, and hi, everybody. I'm really glad to be back again. And yeah, like you said, we're going to start or keep building upon the data analysis and really just take it up a notch with this time my bike, or not my bike, but the bike that I've helped building for Moto America, which is the one that you can see, number 52. It's an SV650, and I'll talk about it a little bit later. A little bit about me. I guess I would say I'm a self-proclaimed race data engineer because I just started, last year, and then I'm growing my own experience and building upon what I've been, studying for the last, 10 years, basically, which is internal combustion engines. And so I have a master's degree from the University of Wisconsin, which has an engine research program. And I am now working at Oak Ridge National Lab in the engine research department, but I've just accepted a job at Harley-Davidson. So I'm finally, mixing passion and career, where I'll be working in the engine R&D department. So that's really, really cool. And in terms of educational video or educational material, so I'm making quick tutorial for AIM systems. I have been working on educational videos as for, a track tutorial. So I'm waiting on new AIM devices like the SmartyCam to really pick up on that again because it's pretty time consuming. Yeah. But yeah, so happy to be back.
And we'll link towards the end of this. We'll put a link to some of Chloé's social media, including her YouTube page, so where you can watch some of those. The perfect. Let's also keep in mind that if you're joining us here live, this will be a bit of a question and answer kind of a period. Well, if you're chatting in the chat box, perfect. I love that. If you have any questions you think that Chloe or I might be able to answer, go ahead and open up the Q&A box on your Zoom setup there and type them into the question and answer box. That way we can pick them and bring them in as they show up there. A little hard to keep up with the chat sometimes. So perfect. So Chloe, let's just, I'll run the presentation on my end here. We're going to talk a little bit about kind of the flow for today. We're going to just chat about what beyond what we've done a little bit already in the past, what are professional racing teams using for sensors? What are the nice to haves? And then we're going to get into actually looking at some suspension data, which is kind of where we're going to head today, and for the most part. And then at the end, we're actually going to jump out of the presentation, jump into some live data, and show you a little bit of that, which that live data is available for you. We'll link it up in the chat box here a little bit, and also in, of course, the description box below. Live data, the data we're going to be looking at is Chloe is nice enough to make available for us, including the user profiles and the math channels as well. So the presentation that we're looking at right now is available for you to download if you want to keep it for later as a PDF and open it later. That link is either in the chat box, and of course it'll always be in the description below. So with that said, Chloe, let's jump in and talk a little bit about in professional racing that in your Moto America data tasks that you have to do. What are some of the must-have sensors that are beyond the ECU stuff and the GPS-based stuff? But what are the kind of stuff that is very important for you to be able to do your job?
Yeah, so we have a basic list that's highlighted here. It's, for me, it's still a work in progress. We don't have all of them, but really the must-have when you're starting a full system that basically goes beyond what you can get that's embedded in the motorcycle. You're going to look at a dash logger or just a logger style like the Evo 4S or the Evo 5, but something that can actually acquire like additional analog channels or additional CAN signal. So we're looking at the Evo 4, the Evo 5, which is basically just a black box, doesn't have a dash. You can add a dash with it. The MXL2, the MXM, and the MXS 1.2, which are different levels of dash logger. Then something that's extremely important is the front brake pressure sensor. And usually the one that we use is the 0 to 100 bar. We have suspension pots. I could try to say potentiometers, but I never pronounce it right. So I'm just going to say pots for the entire presentation. So front and rear, which are usually 150 millimeter and 75 millimeter for the bike that we're looking at, but usually it's pretty common across the board. And then stuff that you can add that are desired. It's really good to have a lambda sensor. So some systems have an ECU that's using a closed loop control, so an air racer system, a Motec system, or you can use the AIM LCU1 system. And then wheel speed sensors that are usually embedded with the new bikes because ABS and traction control sort of depend on it. But you can also add it. And the good thing is most of the sensors are sold by AIM. So you can just go to aimsportline.com and find them.
Let's see, my cursor didn't work. There we go. Here's your next slide.
That's my slide for Matt. Now, when you keep going with the professional racing sensors, you can really go all out. And so I call that the we're not joking around sensors, or probably my ultimate wish list. So, there is a way to monitor tire pressure and temperature with the TPMS sensors. We can also add a rear brake pressure sensor. For, at the professional level, most of those guys are using the rear brake. I never touch it. But, when you start picking up speed and backing it in the corner, that's something that you really use.
Kind of funny, kind of a little story here. I asked you very early on when we were first starting to chat about doing these webinars, I think before the very first one, I asked you, do you ever use the rear brake? And I have a fellow that I worked with for years outside of motorsports at an engineering outfit that we were working at. He also raced bikes, and at locally here in Washington, Oregon, by the name of Scott Soper. Scott is retired now, and he watches these occasionally. So hi, Scott. And I asked Scott. I remember asking Scott, "Do you?" He ran up front, right? Won some championships locally, amateur level, and I asked him how on the rear brake, what do you do? He says, I could take the brake pedal off and it wouldn't slow me down. And it shocked me. And then when I started chatting with you, you said the same thing, but there are times when the professional guys will use it to help do some things. So having that sensor is just one more of those that you stack in there. It's part of their arsenal of things to use. So.
And it's really important because you do want to use the rear brake when you start wheeling. That's what's going to bring your motorcycle down. So, I don't wheelie that much. So in my case, it's not so much of a problem. But yeah, and so, you have other sensors that you can add. Most of the motorcycles actually come with switches when it comes to oil light and, like major temperatures. They're just resistance. You can actually add, real thermocouples or real pressure sensors for everything that comes to coolant and oil and fuel. You can go all out in this. You can also have a lambda sensor in each header for each cylinder. You can also have something that Matt actually brought up, which I think is really, really cool, biometric sensor. So you can have a heart rate monitor that I think it's connected via CAN to the motorcycle. So then you can actually see your lab data and you can actually see your heart rate throughout it. It's really, really cool.
Body temperatures, pulse rates, all sorts of things.
Yeah. So you can really, really go all out. And I think that's, at this point you're getting to the MotoGP level, but it's really awesome. And there is a comment in the chat about mounting or mounts for pots. Mm-hmm. And so that's something that I kind of struggle with. I've found a front ring for the fork from Robbie Moto, which is in Italy. I think it's Robbie Moto Engineering. A lot of shops will just 3D print them. Oh. I think Superbike Unlimited might be able to do it. G-Force Engine Development, which is our engine builder, has been making those for the ESV. So it's just a matter of finding a fab shop for that.
Perfect. And then the lambda sensors in each header. We also have lambda sensors, or we can also do the picture we've got there is just an exhaust gas temperature. So both giving you some pretty good information. I think lambda obviously is the one that would help you the most. So
right, for tuning purposes usually.
Yeah, perfect. The for those watching later on YouTube, one of the benefits of coming and joining us live is we have this chat box, and somebody asked what would wheelies do to the pitot tube speed, and then later on somebody asked, and I was laughing over here. I wonder what wheelies do to the heart rate? Talking about our heart rate monitors. So all sorts of funny stuff going on in the background for those of you that can come and join us live. Chloé, you're working in the system, working in the series, and then you've got a bike that you are building up, adding more and more data all the time. Chat with a little bit about the data that we're going to look at a little bit, and the data that you're going to share with everybody a little bit later, and your little data disclaimer here.
Yeah, so I'll start with a disclaimer. Everything that I've mentioned before is sort of a wish list for us. Our bike is a work in progress, so we don't have a brake pressure sensor for the simple reason that we had issues with our brakes, and there is a little bit of hesitation in opening up the whole system. So that's something that's really, really missing. So the advantage is that we are going to be able to actually focus on, just POTS data, suspension data. We also do not have wheel speed sensors, because so what you're looking at is a third generation SV650. The twins class in the US is dominated by, so the SV650, the Aprilia RS 660, the new R7, which is Yamaha, as well as the FZ07 for Yamaha. So they share the same engine, but different geometry. And I might be forgetting a couple, but so the SV650 is probably one of the longest running bike in the series. And it is basically a super bike at this point. So a lot of things have to be modified. Most of those twins bikes are usually naked bikes, or like bikes that are a little bit more upright. And so a lot of modifications need to be made for to make them race ready. So in that case, we actually have the front end from a GSX R600. The rear wheel is a GSX R600. So all of the wheel speed sensors that were integrated have been, they're gone. So we'd have to have like an aftermarket wheel speed sensor. So that's coming, hopefully. We are using an MXL2 dash with, the AIM sensors, so AIM potentiometers. We're tapping into the harness to get the TPS. I had to do some modification to get the RPM and like just basic temperatures, but it is still a working process. And so we have front and rear all-in suspension, and we have a Dynojet auto-tune system that has the wideband lambda sensor. We do not have an aftermarket ECU, but we will eventually, which is none of that. It's not our problem for today. But yeah, so we're looking at front and rear potentiometers, and we have so you can see it in the middle section. You can see it like in action.
The front shock sensor.
Yep.
And the rear shock sensor. Our mutual friend Chris Lessing mentions that Graves Motorsport sells some mount kits for mounting shock pots on different models of bikes as well.
Perfect,
We were talking
Chris.
about earlier.
I need R1 mounts. I'll get with you.
There you go. And anybody else that's watching, contact Graves for some of those different things. Perfect. So once we get the loggers on the bike, and we get the suspension sensors, kind of focusing on what we're going to chat about a little bit in more depth today. Suspension travel. Let's chat a little bit about, and I know this is you're at the beginning of the learning curve as well, although you've done a little bit of it and certainly learned a lot already. Chat a little bit about suspension data basics. Okay, I've got this suspension pod on the bike. What am I looking at? What am I trying to get? What's the end result I'm looking for at this first level?
Yeah, so we're looking here at it's an excerpt of my user profile, and I'll be actually adding a couple channels when we get to the live data. So first of all, I am not a suspension person. I am learning here. I'm totally coming with an engine background, so my specialty would be tuning bikes and looking at engine maps and stuff like that. So I have to give a lot of credits to Chris Lessing from Graves, who's actually has been coaching me a little bit. Neil Vasavada from Apex Peak Technology, who's in California, and then I've been also working with Eric Vallarta from Velocity Calibration, who also works with Robem Engineering, which is the leading team in the TwinScap. And these people really have sat down with me and walked me through sort of the process to look at data, and it's been learning an art at this point, but it's really interesting. So when I'm starting looking at my data, there are a few things that usually strike out. And first thing that we can look at is the behavior of the bike under braking. So are we bottoming out the suspension? And so we can see that simply with the fork travel, so usually we have about 120 millimeter to 130 millimeter of travel. So we can actually see how much of the suspension we're using. We can also see when the bike is, when the rear wheel is lifting under braking. And if the rear wheel is lifting, well, we lose all of our electronics. We really need to have that traction on the rear. We really need to have that wheel speed for most of the advanced bikes. So there's something that is really crucial, is how to keep that rear wheel on the ground. And we can also see that. So for example, if the rear wheel is completely extended, you'd see, the shock potentiometer just going down to 0. Yeah. We can also detect wheelies. So under acceleration, and that's why I have the TPS all above there. Under acceleration, you can see whether the fork is fully extended, and that's where you'll see it going to 0, as well as how much the bike is squatting. And so if the bike is squatting, then you'd be bottoming out the rear. And so those are like the extremes, or the boundaries of what you can look at. You can also start looking at mid-corner behavior. You can also start looking at chatter. And the chatter is usually easier to look at when either looking at the frequency or the velocity, which is just the derivative of the displacement. We can also see bumps on the track, which you can actually see on that little image. And it's actually really cool. Chris mentioned something that I thought was awesome. You can see and Roger actually mentioned that as well. You can see the wheelbase of the bike whenever you have a bump. So if you zoom on that, and I'll zoom on it later, you can see that the front wheel goes over the bump first, and then the rear wheel goes over the bump. And so you can actually measure the wheelbase. That teaches you the weight distribution, and then just like the overall behavior of the bike under acceleration, braking, mid-corner. And what I do usually when I see that is, I see everything that I try to make a note of everything that I notice. I think about a few suggestions that we could make. To me, it's easy to say, oh, we need more damping or we need less damping. To then choose whether we need preload or compression or rebound, it's something that I usually discuss with our suspension guy. So we have Olin's reps at the track that sort of know our bike and then show up. And then, like I mentioned, we have Chris and Eric that have been really, really helpful for that specific stuff. So those are the things that I'm still learning is, once I have the data, how can I actually change the geometry of the bike or the suspension settings.
Perfect. There's a couple of questions here that I thought we would maybe throw in here just really quickly. You may or may not know the answer fully. Well, although I will mention in the chat, Chris says, do not mention chatter to a suspension guy. It scares us. So it's a difficult thing to work with and understand probably. David asked, do you think, just chatting with you, I haven't heard you chat about this with me at least, but do you think you'll be able to pick up aero load out of suspension? So you're hauling down the front straightaway. Does the front start to drop a little bit more? Does the back? Have you ever considered yet looking at your suspension travel and understand the aero effects on the bike?
I have not looked at the aero effect on the bike, but we can definitely detect it. That's actually a really good idea. I don't know if that bike is fast enough to really pick up that.
You have that problem too. So,
but no, that's actually really fun. Like under acceleration, once you're on the really long straight, like Road Atlanta, for example, to see if like the bike just sits a little bit,
how it settles in as you're riding, and the bike position is so the rider position is so important on how the aero is hitting the bike.
So is that something that's being mentioned or that's being looked at in car racing?
Very much so. That I think the fact that the fellow that David asked the question has a heavily aerodynamically influenced car, and that's one of the things that they do to look for aero balance is try to understand, is it at speed are you adding a ton of rear downforce and none on the front, and then all of a sudden the car picks up a high speed understeer kind of a thing.
Yeah, and Rick is mentioning that you can actually see it when the bike is slowing down, and that the bike would be fast enough at David is mentioning that 60 mph is usually going to be fast enough.
Yeah, and Daniel also mentions, and Daniel mentions in the questions, do you account for top out springs at all in your suspension travel? I don't even understand that question all that well, but what do you think about that?
Yeah, and so again, like now we're looking at stuff that's a little bit out of my wheelhouse, but the top out spring is usually something that I look at into motospec initially. So
which we'll talk about a little bit later.
Talk about a little bit later. But when it comes to sort of doing a trial and error system or trial and error setup, I have I would call it kind of a simulation package from Motospec, and that's where we start plugging our numbers and actually see how that would affect the the wheel rate or the wheel force, etc.
Through all the geometries and all the some of the complex stuff on bikes that way. Yeah.
Because changing the spring is not always the right answer. There are other things that you can change, and there's also other faster adjustment that you can make, but everything is going to affect it. So it's really interesting to actually see whether it's the top out spring, whether it's a little bit of preload, whether it's like the swing arm angle. There's a lot that's way over my head for now.
Exactly. When you look at your data, you've kind of set yours up in certain ways. Let's we're going to look at some live data that's going to show a little bit of this, but maybe you can go through what you basically look at, and then we'll look at some live data here in just a moment.
Yeah. So that's my main user profile, and that's something I was working on with Chris yesterday. I've actually modified it just a little bit, and I'll kind of go back and forth. But something that I look at is the GPS speed and the TPS and the throttle position sensor to sort of see the action of the bike. Something that I don't have here that's actually really good for suspension is to have the altitude. So I can actually add it later. Then we have the front velocity, which is the derivative of the front travel. the front travel just below, the rear travel, the rear velocity, and then the lean angle to also see, you know, when I'm mid corner or on the straight line.
Perfect. So your top and bottom graphs that you hear are just kind of home base, right? My speed with driver inputs as far as changing the effect, and then the left and right of leaning it, and then the rest of it is the true suspension data itself.
And something that I have on my live data, I'll have, so again, we don't have the brake pressure sensor, which is sort of a big miss. However, I'm always calculating the braking acceleration or the braking deceleration, braking G. So, you know, we don't really know, it doesn't help us make the difference with it between the engine braking and the actual braking, but it still tells us when the bike is slowing down. And so that's also something that I have on my user profile that I'll show later.
Perfect. Let's jump to the next slide. Let's talk a little bit about suspension data basics. You know, we'll spend a little bit of time at this page, and one of the things that I would suggest at this point, and maybe Robbie can put it up into the link up into the chat, and obviously we'll have it down in the description below. I did a kind of a basic run through of the suspension analysis program, the function inside of Race Studio 2 analysis. And a lot of what Chloe's going to talk about here, we go into just some of the basics in more detail in that video. So if you find this, what she's about to chat about, a little bit interesting, and you want to try it with some of your own data or the basics, I go through a lot of the stuff that we don't want to take the time here, or since we already have it in another video, for you to watch that one and then continue on with this one as well. So Chloe, go ahead and talk about a little bit about what you're starting to look at when you open up the data, your suspension data in Race Studio 2, and look at it in the suspension function.
Right. So when I first started getting, suspension data, I was sort of looking for ways to analyze it, and I just didn't really know where to start. There's this really good website called Data MC that is, and I forgot the name of the person who's running it, but it's somebody who's got a lot of credential in the motorcycle racing area. So he has this website that has a lot of tutorial on different data analysis. So I've actually linked the reference below the histogram.
Right down
but
here
one
below.
way to look at data, I have like a really quick look at how the suspension is behaving, is to do it's a histogram that's based on the probability density function. So it actually distributes the velocity as a function of let's see, I'm just going to open it to make sure I'm not saying anything stupid. So it's velocity as a function of velocity. It's a distribution. And the reason why this is actually really useful is that there is sort of a target. So for me, starting with suspension data, I'm sort of looking for, values that could be, that could be my target. So the first thing here is that it's very important to set up the boundaries of it. So the boundaries of the velocity, which I think for the front is usually about 500 millimeter per second. And then for the rear is about 200, 250. And then you need to set up your, your transitions. And once you have that, you then have 4 zones, which are your high speed compression, low speed compression, high speed rebound, and low speed rebound. And in theory, what you want is some kind of an equal distribution within those 4 zones. And if you don't have that, if you have too much high speed, then it actually tells you that you need to change something. So let's say that you have a spring that's too stiff, you're not going to engage all of it, and so you're going to have a lot of time in the low speed zone. So you don't want something that's a histogram that is too tall. You don't want a histogram that is too flat. And so having this normal like Gaussian distribution is something that, for me, helped me at the beginning. There is a lot more to it, but I felt like it was a really good starting point. So AIM actually has a suspension analysis window that makes those histograms. And that's what you're seeing in the blue and the red. And you can set it up, and I'll go over how to set it up. I'll also maybe mention how to set up the pots in RS3, or maybe we can just like link a video to that later, because it's really important. The way, like in suspension analysis, garbage in, garbage out has never been meant more. I think you really need to pay attention on how, what the frequency of data acquisition is what your, and what your boundaries are. But once you have that set up, it's a really, really useful tool.
We have some documents that we've put together. If anybody watching this either now or in the future on YouTube wants it, just email me. The email address will be at the end, and I'll email you these PDF documents that talk about. One of them is it's configuring and calibrating steering, suspension, and throttle sensors in Race Studio 3. A step-by-step tutorial to walk you through and how to understand that. So and just to reiterate what Chloe said a second ago, when you start to look at these histograms that we're looking at on this page, typically your shocks, often in your shocks, are going to have high speed and low speed compression adjustments, right? And on compression and on rebound. And so when you go to look at this, you want to make sure that shock is spending the amount of time in a certain area, that you're dampening the right area at the right time, and to make the bike as easy to ride as possible and fast. So this gray line that you're looking at here, this box, it's definable by you. You look at your shock information. If it says that that first inch either side of 0 is what we would call the low speed, maybe 25 millimeters of speed, millimeters per second. Maybe that's where the low speed dampening works. So we set that up where you can see that very clearly. And then if you see that this is way up here, way high, or if it's way low, you can open up or close those valves and begin to get this histogram in this normal curve, and that Chloe has described here. And so it's and then it ends up becoming a bit of a, there is this perfection that Chloe talked about, 25% in all 4 quadrants, and then, but maybe that isn't perfect. That maybe that's not the fastest for that rider, that bike, that track. But at least now you've got every time you download your data, you can make an adjustment, see how much it has changed, and then pretty soon you got a pretty good idea of what changes make. What they do to the data, and you know the speed of the bike and what the rider feedback is, and it makes it much quicker and easier for you to make those changes. So hopefully that it reiterates what Chloe said about that. So okay, the next slide is, oops, perfect. And Chloe, then inside the Race Studio 2 analysis suspension analysis function, we're not just looking at histograms, but there's some other things there too that you have found that you've enjoyed using. Talk a little bit about this screen that we will actually look at later in the live data as well.
Yeah, so this is the suspension analysis window that's integrated into the AIM RS2 analysis. It's the advanced mode. So the basic mode will only have the 2 histograms that I showed in the slide before. But whenever you go to the advanced mode, you actually see a little bit more. You have now the front travel, which is also duplicated from the the main channels to like the main channel window, sorry, to the suspension window. Then it automatically calculates the velocity, and you also have the frequency. Which I don't really use a lot, but talking to Chris yesterday, he actually showed me what chatter looks like, the C word again, on the frequency, and it's actually a really good tool to pick it up. And so you have that duplicated for the rear as well. So you have the shock and the front. What's really, really cool, I think, and to me, because it's like I'm looking at basics and I like to look at the histogram. The histogram calculates the percentage in each zone right away, and so that allows me to have like a really quick look at how much we're engaging the front end. And I think one of the issue that we've had so far, and I think we've only used the suspension pots for 2 rounds or maybe 3 rounds, but I feel like we've always been too stiff on the front, and I've never had like a really good distribution on the front because we were maybe not brave enough to go with like something a lot softer. We've made like small iterations. So, in the data that I'll show, I have 2 races where we went down a spring rate. So we went down from a total of like 925 to 90, because you can have like 2 different springs on each fork. And, you can see a little bit of a difference, but it's not that crazy. The limitation with the histogram is that, it's going to calculate everything within the bounds. So if you have anything crazy on the high speed, you won't see it. So you have to be mindful of that. But again, that's to me a really good tool, and it's something that helps me pick up, anything crazy.
And like normal data things as well, that where right now we're just looking at a single test, but if you had one, you made a change in shock spring, whatever setup, we could bring the second lap right on top of it, which is something we're going to look at in the live data here in just a moment. So very, very powerful tool. Let's see, let's go to the next one. The next one is just reminding me that we're gonna open up the live data, and what I'm going to do is I'm going to stop my share, and
Okay.
Chloe is going to share her screen. She's going to run the data locally on her side. So it should pop open any second for everybody. There it starts coming. There, everybody should be seeing it. I see it on my end. Yep, go ahead.
So you can see, I guess we landed on that suspension.
There you go.
So
perfect.
That's perfect, right? Perfect, seamless transition. I can definitely start with how to set it up. So it's this little, and I don't know if you guys can see it really well, but it's this little shock icon that you have on top next to the time distance and the engine management. And just to take a quick look at the settings, if it decides to show up. Okay, can you guys see the settings?
Yes, yes.
Okay, so on the settings, you have the basic mode and the advanced mode. Here, we're looking at the advanced mode, and you have like all of your setups here. So you can set up your high. So here on the front suspension, you do have to choose your channel, your suspension channel. Then you can start looking at the transition, which is actually that gray zone, boundary between the high speed and the low speed. Then you have your full travel for, the potentiometer, and then the speed and of scale, which is on the suspension speed here, which is your limit. I'm not using the D-forces stuff. I'm not using all that part right now. I'm just like sort of focusing on this. And then you also have the same thing on the shock. Something that's really important is all the calibration is done in RS3. And the setup of the data acquisition rate is also done in RS3. So maybe if we have a little bit of time, we can look at that.
What we're looking at here is just the settings for actually taking data that's already been gathered. And that document that I mentioned, we'll go into the Race Studio 3 setup side pretty in depth.
Right. And then you have like different tabs that are looking at just how to display the different data or the different windows.
Very, very powerful function.
Yeah. And if you want to move between the basic and the advanced, you're going to have to restart the application, but that's all good. So, all right. So looking at, we can start looking at this. Some really powerful feature is that, whenever you're zooming into an area, so which is here, which is turn 3. Oh, by the way, we're looking at Brainerd data. So Brainerd, Minnesota, from a couple months ago, maybe a month ago. Moto America round, we had 2 races on the Twins Cup. And it was actually really weird. I'm going to bring in the map. It was actually a really weird track because we had the pit lane in a different area than we had the start finish. So the start finish was right by turn 1, and then we had the pit lane here. So there was actually a lot of back and forth involved. But so here we're looking at data in turn 3, which is really, really hard braking. And, you can see that the suspension travel is pretty flat. There's not that much going on. You're looking at, a travel that's about 86, which tells us that even though this is really hard braking, we're not using all of our front. And so, here I'm wondering, are we too stiff? Like, what's going on? So this is usually where I start going into the histogram, and, you can see that the low speed, we're at 35%. I have my boundary at 50, I believe, 35%, 29%, and we don't have a lot of high speed. So this is telling me that we could actually go softer on the front. And, when I'm going back to, so I have a suspension graph here, you can see that looking at the entire lap, we're really not engaging the whole travel anywhere. So Suspension, front suspension, I have my maximum at 95, and we determined that our maximum was at about I think it's 129 millimeters. So there's really some work that can be done here. And as I was talking with Chris yesterday, he also mentioned that it's possible that our rear could actually be too soft. So, you know, we're not perfect. There's a lot of work to do. There was a lot of work that was actually done this weekend, that weekend at Brainerd, in conjunction with Motospec. Other things that are really cool, I think, when looking at suspension data, and I just want to make it back here. So here you can see like two weird events, which are bumps into the track. The track was actually really, really bumpy. And you can actually start seeing, you know, like I mentioned earlier, like we can measure the wheelbase. And I'm sorry for purists, I'm in feet. But, you know, you can actually see like 5.5 feet. I actually think this is really cool because to me, that's a double check on how I made my calculations or my measurements on the bike. Another thing to look at, like I mentioned, right here, we are at about 3 millimeters. So it means that, you know, the front is fully extended. And if you're looking at it, it's, you know, on the exit of the chicane, which I think they call the Joker at Brainerd, and back onto the front straight. So here it's like really hard acceleration, and you can see that's why I have my throttle position here.
And what's interesting to me about that, if you look at right where your cursor's at, both front and rear are nearly at full droop. It's like there must be a little bit of a launch pad right there.
Right. Yeah, that's really cool. And so, yeah, and then you can actually see one of our biggest braking area, which is this turn 12 right here, where, you know, we kind of nosedive, and there's probably a bump, I think. Wow. This is really interesting, and I don't really know what to think about that, but it's like the little bit of a movement on the front, and the rear that's like completely almost fully extended. So this is the kind of things that I'm looking at, and it's really cool also to see where the bike sits during a mid corner. So, you know, full braking, and then, you know, you are transitioning. So by around the apex, you're transitioning from releasing the brakes back onto the throttle, and it's really cool to see, you know, where the bike sits. You know, a rule of thumb that I've heard is that you kind of want to be in the middle of the stroke for the rear when you're in mid corner, and here we're at about 20. So, you know, we're not too bad. I think 18 to 25 is probably 23 is probably a good area to be in, considering that the full stroke is usually about 50 to 60.
My guess is it would be a very bad moment if you're mid corner, laid over, really compressed into the track, and you bottom out on the rear. That would instantly make things happen. So I understand why Chris and you were mentioning that. Yeah,
exactly. So let me see if we have any comments at all.
David Arkin mentioned he asked, how do you determine those boundary parameters? Those are really, David, you get some data. If you have shock bots on your car, you would go look at the speeds that are happening, and it's really just, it's data specific. Her numbers are probably fairly close for most people, but you would go into those settings that you mentioned wanting to see when then she did actually open them, and then to see where all of your data fits, and set up your parameters to kind of fit it. So it's not where you can just say it's 1,000 millimeters per second, and and the transition is always 25 millimeters or something, right? It's there is some variation in different shocks and suspension packages.
Yeah, and so Kyle mentioned asked what track it was. Perfect. So this is Brainerd, Minnesota, and I'm gonna bring in the track map again. All right, and so, okay, somebody mentioned lots of brake throttle overlap and slow throttle release. So yeah, we also have we have some work to do on our hand control. But again, this is not the brake pressure. This is just the G, the acceleration or the deceleration for braking, because I do not have a brake pressure sensor. And trust me, this is something we're working on.
That's kind of cool that almost every data logger will have that longitudinal G. You have done a little bit of work with it and flipped it, but you can actually see it. So even without a brake pressure sensor, you've got a basic idea. Brake pressure sensors are obviously always better.
Yeah. And yeah, here Matt was actually saying, which is actually really cool. If you start zooming into what's going on in that area here, is it looks like he's, he was on the brakes and then he released the brakes a little bit and then go back on the brakes. So almost like, he realized that he didn't brake enough, or maybe there was somebody that he was about to rear end. That was a pretty treacherous corner right there. So there is a little bit of movement here. So that's, this is, probably what happened. Just like get on the brake, release, get on the brake again. Those are really cool stuff.
Perfect. As you're finding your way to the next thing you want to cover, Stefan asked a question on the front and the rear. You're sampling. What is your sampling rate? And do you filter because the traces are not very noisy? They're easy to read. Stefan, I happened to look at this data a little bit. I think they were 200 hertz. Was the data that was gathered here?
They were 500.
500,
hertz, which is a little bit too much.
Yeah.
And that's where actually that's a really good segue into showing the velocity.
There you go.
Right here, and I'm just going to move the.
When you say 500, maybe it's a little bit much. You're thinking about slowing it down to 200.
Yeah, I think we want to slow it down to 200.
Okay.
I'm just going to bring the brake up.
And while she's doing that, Stefan, I've got an email to you, Stefan, that I've got a solution to a question you had. So get back with me and we'll do a Zoom and I can show you a little bit of what I think I have found a way to work around your problem.
Yeah, so here when we rear click on the channel, you can actually see the sampling rate.
There you go.
I tried to lower the calculation for the velocity, I tried to lower it to 200, but the sampling rate for that is 500. And that's something that I'm actually going to change as I'm getting to, the next round. But something that's really cool is that there's an integrated filtering number right here. So you can actually, apply and see how that actually changes. If it changes a little bit, I'm not really sure.
It will a little bit, but it's with suspensions, they're moving so fast that the filtering,
it just brings it down a little bit.
Yeah, just a little bit. So
yeah,
you're much better doing it with the speed and adjusting it there a little bit.
Yeah, so here you can actually see, the movement going through and the velocity, which is, this is actually a little bit better than looking at it into the suspension analysis, because the suspension analysis, you can't really move the boundaries right here. Whereas, when you have your own channels, it's a little bit easier to actually,
not quickly at least.
It's actually easier to just adjust it. And, here, for example, you can actually see that when we're getting into that turn 3, there's just not a lot of movement, and that's not something that's desirable. Some other rule of thumb that I abide by is I'm hoping when I'm looking at the front, I don't specifically want to see anything too flat. And I do want to see a front travel that sort of looks like a brake pressure trace. So, the brake pressure trace, the idea is to have a shark fin. So, you're loading the front tire with the initial, the initial 95% of braking during the first 5%, and then have that tapering off. So which, would maybe look a little bit better here. And this is just too flat right here. There's just absolutely no movement. So, that's definitely an area that we can work on.
Okay.
Right here.
Anything else in the live data that you wanted to, you have several different tabs across the bottom. Yeah. As she gets ready to talk a little bit about those, we're kind of running up against the time a little bit. The data that she's using here, the user profile, so you can make your screen look exactly like hers. The math channels that some of the stuff she's done here, and of course the presentation are all available for you, and they'll be in the description of this YouTube video when it gets up a little bit later, just so you can download it and then rewatch this, and you can walk through some of this if you don't have your own suspension data. And
so Mike Canfield, hi Mike, also mentioned squat and anti-squat of motorcycles. So that's also something that we can plot. And actually, when I'll make my segue to MotoSpec, there is a really cool feature of MotoSpec that allows you to export math channels. So MotoSpec is this chassis program that helps you just sort of set up and simulate what you can do like how your setup is going to affect the motorcycle and the geometry of the bike, the wheel rate, etc. Whenever you have all of those constants set up, it creates a set of math channels. So you can actually plot swing arm angle. You can actually plot anti-squat and import that directly into AIM without even having to make those channels manually. It actually just like builds upon the math channel file that you already have, which is really, really cool. The only downside is that you have to export it for each each setup. So you'd have to have like a different math channel file for each setup that you're doing. And Daniel is saying that he's really ruling off for turn 2. Yeah, we talked about that. Here, turn 2 is a little bit scary. He's a little bit slow on it. Also, Daniel, you're not allowed to look at those data because you're a competitor. We should block the data. We should actually block John's data just for Daniel.
Yeah, there you go. No, perfect. Every bike is going to be different. She has set this up to be to look at in the advanced graphs that she was showing earlier was for a bike. If you tell it it's a bike in your initial settings, it understands that there's just a front suspension and a rear suspension. If those of you that have car data, you'll tell it it's a car, then you'll have all 4 corners of the suspension as well. So here now she's bringing up a second test after they did a change, and pretty quickly go through this just to show a little bit of the difference, and then we'll continue on back to the presentation.
Yeah, and I think we're kind of running out of time. So as I was mentioning, I thought that we were a little bit too stiff on the front, and so we actually went with a spring rate softer, and you can actually see that in the data during race 2, which is the yellow one, we started engaging a little bit more. So you were still kind of flat here with not a lot of movement. So there's definitely something to be done. And that's where I would actually go talk to my suspension guy, just be like, okay, what should I do here? But we are definitely using a little bit more of the travel, even though it's not all the travel. I think we're going up to, from a maximum of 95 to a maximum of 97. But it is a little bit of progress, and that's maybe where as a team we could just be a little bit more brave and just go a little bit higher or a little bit softer. But we definitely see a little bit of a difference here in engagement. And here there's the bump that we saw. It seems like either he took a different line or we were able to dampen it a little bit better. Probably a different line because I think it was a pretty big bump.
Yeah, it looks like a pretty good one.
Yeah. So I guess that's maybe what I wanted to show. We can move to the suspension analysis, and when we go to the test compare, we can actually see a little bit of a difference. And really, the bins in that histogram are not. I guess they're not fine enough that you could see that much of a difference. But that's a function where you can actually see and compare different tests. The only downside is that you don't have the distribution with the numbers, but they're actually calculated in the individual tests here.
Exactly. So. And you can also set up your screen where it's nothing but the histograms, right? So you get a little bit more granularity. It's the same data looking the same way, but with more screen space, we can begin to see what we want to see a little bit deeper. A great overview, a great place to start is a setup like this, though.
Yeah, I can maybe send you off and stop sharing my screen.
Perfect. And let me move this over here. And let me reshare my screen. Share screen. Boom. And there we go. Perfect. There's a couple questions here why we kind of move on. Why would you want to reduce to 200? Stefan, it was just a matter of, when the higher frequency rates, maybe you do see some neat things and you see some things, but you just end up with all that additional noise noise as far as more squiggly lines capturing every tiny little thing. In some cases, with some shocks and some suspension, you're going to want that. But where she's at with what she was doing here, it was more of a writer program trying to understand the depths of the forks and the rear travel, and a little bit of a slower rate is going to give us a nicer, cleaner thing to look at. So Art asks, are there any measurements that can predict the tendency to high side going over the front wheel in a corner? It's certainly not something you want to do, and we don't want to see any riders doing that. I'm not sure of a way to do that in the data. You can answer that question if you want, Chloe.
You can definitely see when the bike high-sided.
When it happened, but you don't see it as it's coming up, probably.
I would just take that question and send it off to Chris, and there is probably, some you could have like predictive models. So if
some
you
sort
have
of
data,
tendency, something is you can see something coming, right? Yeah, probably.
And potentially, just looking at the speed and how the suspension are actually being engaged. And maybe if you have data from a bike that high-sided before, that could probably give you some information on what you're looking at.
Yeah,
that has not happened to us yet.
Luckily, there's this program that you mentioned in our chats ahead of time, and that we're showing a screen capture of it. It's called MotoSpec. I remember a year or two ago, they had this program, and they were working with different data systems, and they wanted to be able to integrate with AIM, because a lot of their customers, a lot of motorcycle racers have AIM data, and so this is not a data analysis program, but it's rather you plug in all this information, and it is helping you understand the geometry of the bike and all of these different things, and it's a great tool to work in conjunction with our analysis program to help set up and make sure your bike is set up correctly before you start. I know you're using this, and you mentioned to me that most of the folks in the paddock area at the races in the Road America series are using this program.
And the Moto America, yeah, any bigger team is going to have something like that. It may not be MotoSpec. It could be something. I think there's Suspec. There's another one created by Calyx, but it's Excel based. There's a lot of equations in the background, but to me it's been really useful, because if somebody just tries to explain to me how the bike is moving and how many clicks of compression you should add, and that's just something that I find fairly overwhelming. However, whenever I'm presented with equations and plots, that's something that I can just reason with. And I found that very, very useful, because numbers that you're looking at are usually your ground trail, your swing arm angle. These are all calculated as a function of all the geometry that you input. The advantage of MotoSpec, which is not so much of a big advantage for us since our bike is such a Frankenstein, but MotoSpec has geometry from all of the major bikes that are available. So they have measured all of the bikes, and they have the geometry that you can input. So you can already just have a base file and then start making your modification on that. And Jeff Laitman, who is the owner of MotoSpec, is extremely useful. So I've had a couple of issues with my computer, and we're working together. So he's very responsive. There is a really good there's a really good manual for it, and this is really complementary. So it actually really works with AIM, and you would just use that between sessions, or ahead of a weekend to just make decisions, and then you see the effect in the AIM software. So it's been great.
It's a parallel piece of software that you would use to help with the simulation and understanding why you're seeing some of these changes in the actual AIM data. Perfect. And to kind of close it all out, there you're in the process of learning a ton of things, and one of the things that you can do is there's a lot of other suspension resources out there. Chat about some of the different ones that you've got here.
So DataMC is a website that has a lot of tutorial. It also has some really good Excel sheets that they're kind of blocked, but you can just input a bunch of your data and it spits out results. So it has that for gearing, it has that for suspension, chassis. It has a really good setup for the histogram as well, where you can start looking at playing with numbers. It's a really good technical reference, I would say, and a really good place to start. Then there are a couple of books that I own. Sport Bike Suspension Tuning from Andrew Trevitt is, I kind of want to call it the suspension for dummies. So if you've never even touched suspension, it's a really good way to start. For me, there is a little bit too many words in it and not enough equations. But then you can take the
engineer in you though.
Yeah, but then you can take the opposite of that, which is motorcycle dynamics from Vittorio Cosalter, who is a professor at University of Padova, I think, is in Italy, which is one of the main reference for motorcycle dynamics. And this is not a, it's not a book that you read. It's actually a textbook. It's a real textbook for dynamics. So it is very, very equation intensive for that one. But I found some really interesting information on it, especially when it comes to trying to simulate, tire deformation and really understand the dynamic of the bike. And then the next one, which is kind of in between, is the racing motorcycle from John Bradley, which will take you through a whole chassis setup. So the subtitle says Volume 3, an introduction to chassis setup. So it talks about basics of suspensions. I have not gone through all of it already, but it goes through all the suspension, and then at the end actually has a chapter that's talking about all the software help that you can get. So it covers MotoSpec and it covers AIM as well. So 3 great reference. It's really hard to find references for suspension analysis. So if anybody has links to share, I'm all ears.
Absolutely. And we will have Chloe back in the future. I've seen a couple of notes in the chat, and if she finds any more, we'll probably end our most of our other any future webinars with a page like this, that some stuff that she is learning, since she is on such a steep learning curve, understanding and learning about this stuff. She'll probably want to share some of the stuff she finds as well. So we will do that as well. So, anything you want to kind of close that out, this page, Chloe?
No, I'm building my motorcycle library, and I think working for Harley, I'm probably going to have a lot of additions to it. So stay tuned, and I'll take any recommendations for books. Yeah,
absolutely. Perfect. The this webinar that we have just chatted with and had a great time learning a bunch of different things will be up on our YouTube site shortly, within an hour or so, maybe 2. It'll be up there. It'll be our 174th video that we have up there. Just a great place to go learn. Find all of the webinars we've done. I've renamed and renumbered all of the live webinars we've done with a numbering system. So hopefully that'll make it a little bit easier for folks, from what I've been getting information from others, that has helped them understand the order that they were done. We try to make each one a standalone version that you can just sit down and watch it, but sometimes we refer to other ones as well. So perfect. That'll be available for you just shortly. All of us are going to be heading out to the tracks this weekend, and make sure if you're going to go out there and have a great time, make sure you look for us. We can't be everywhere, obviously, so we have a number that you can give us a call leading up to the weekends, or even sometimes during the weekend, if we have an 800 number there. If you have any questions about any of your products, software, hardware, give us a holler. Let us help you solve your problems, and make sure your weekends are filled with fun. So we're looking forward to that. The our next webinar, we always introduce our next webinar at this point. This coming Tuesday, we're going to have an author of a book come on and join us. It's a fellow by the name of Chris Willis, and he's written a book all about developing a champion, the electromotive Nissan GTP story, and in it is just a wonderful book. And we've done some authors in the past with data, and we'll kind of be focused on the electronic side of this, but he has so many great stories. He was there for that huge program that was a big part of the American IMSA racing scene, and they raced those cars at a very high level and did very well with them. So we're gonna have a good time. Chris was a big part of that. He brought together tons of other folks that worked there at the time, and a great behind the scenes look at developing a race car at that level. It's something you just don't get to read about or talk about very often. So Chris is going to be with us. He's going to talk about some of the different things, and the book is for sale. So if anybody wants to go do a quick search for it and grab it before then, and maybe you'll have some great questions for him too. But interesting fellow. I had a chance to chat with him earlier this week, and he's seems to be just a great guy with just a wealth of knowledge about this program. It's going to be fun. It's going to be fun to do. So we'll look forward to having Chris joining us here next Tuesday on September 7th in our webinars. A little contact information. I mentioned earlier that you could give me a contact. There's my email address there, roger@aimsports.com. I've got 3 documents that I think we kind of chatted a little bit about today. They're calibrating or configuring and then calibrating sensors, analog sensors that you may have on a car or a bike. Throttle, steering, and suspension. Walk you through step by step how to configure and then bring that in, and then of course calibrate them so they're working well for you. Make sure you drop me an email. I'll happily email all of those out to anybody. Also, Chloe was kind enough that all of the data that she used here, not only the presentation, but also the data and the user profile, so it'll look exactly like what we what she was just showing you, and the math channels. You know, there was some math in there that was happening in the background. She has made all of those available. Those links will be in the description box down here below, where you can just download those zipped files, unzip them, and then bring those into Race Studio 2 and take a look at them. So it's a very helpful. So you can take a look at what we just did with that very data and kind of walk your way through the hour-long presentation of Chloe talking about suspension analysis on the bike. Perfect. Chloe, anything else you'd like to kind of add as we close this one up?
I'm working on a website. So like I mentioned earlier, I will have a website with AIM products specific to motorcycles. I will have all the videos that are linked there and tutorials, and also, you know, my services if you guys want to do one-on-one sessions. This is probably going to be launched in October, I believe. But yeah, stay tuned. Hopefully for the next webinar or the next one after that. We'll see how many more we do. But I'll have that, and I'll link the website in the webinar.
Perfect. We'll get feedback from this one. I've seen some feedback in the chat. You know, great session. Make sure you invite her back again. We certainly do. We expect to have her back maybe in about 6 weeks, right? Well, we've chatted a little bit about where that kind of fits into her schedule and the racing season slowing down and some other things, and for her to be able to prepare and do another one where we continue to look at suspension a little bit, but add in hopefully from what she was saying, maybe some brake sensors and some other things that she's talking about. So she is continually building up the bike she works on in Moto America and other bikes as well. So she'll have some other data to share as well. So perfect. I appreciate you coming, Chloe. It's always a pleasure to have you here. Just a ton of knowledge and from a slightly different perspective than what we do with all of our 4-wheel racers. We really want to continue to work with and build the 2-wheel racing knowledge as well, as far as the AIM product. So appreciate you coming. Look forward to doing another one. Again, thanks everybody for coming. Hope you have a great time this weekend at the track, prepping your bikes, getting ready for that. It's going to be a great time. And join us here next week for the book about the Nissan GTP program. Looking forward to that one. Thanks everybody for coming, and we will see you next time.
Thanks everyone. Bye.